This is Pocket, and he's a super small but very capable AI assistant. Hello, Pocket.
Hello. How can I assist you today?
What is the weather in Atlanta like today?
Weather for Atlanta. Precipitation 20. 1C, humidity 80, wind 9.
But the best thing about Pocket isn't just what he can do, it's also the fact that he's ran entirely on this and locally. And there's a lot of benefits of running AI completely local. First, it's 100% free of charge. You don't need to worry about any subscriptions or any extra API fees. And then also your data is 100% private and is 100% yours. You do not need to worry about these large companies stealing your data to try to sell you something. But as powerful as a Raspberry Pi 5 is for its size, if we even try to run a decent sized 8 billion parameter model on it, it kind of runs sluggish, and anything more than 8 billion parameters is probably not even possible to load up on a Raspberry Pi at all. So the question is, how do we make a useful AI assistant when it needs to be local and we're already limited by hardware? So instead of just having one large model that tries to do everything, the best way to go about this is to have a group of smaller models kind of working in a network. And then when they do all work together, we have an actual useful AI assistant that runs 100% locally. So the first model that I want to work on and add to the network is going to be like your main reasoning model. So it's very important that we pick the right model for this because it needs to be smart, but it also needs to be quick. But thankfully for us, open source large language models in the past 6 months has been like progressing at an insanely fast pace. So there are a lot of good models currently on the market. And 3 of which I heard very good things about: Qwen, DeepSeek, and Gemma. So I designed a test that's going to test the model's speed, memory usage, how smart it is, so we can actually make an educated decision on what model we're going to go with. So I'm looking at the results, and at first glance, it makes sense. But what I didn't really expect was for the gap to be so small in accuracy between Qwen and DeepSeek. DeepSeek did perform the best with 85%, but Qwen got 70%, which is only 3 more questions wrong. And it was also about twice as fast when it came to tokens per second. So just from this alone, I'm already leaning heavily towards Qwen, but Qwen does have one little secret weapon that might be able to give us the best of both worlds. Qwen is actually a thinking model, which means it could think through and reason about answers. Like if you ever use ChatGPT or Gemini now, you'll notice a little button where you can see the AI's thought process. Well, Qwen could do that as well. The first test we ran it with it off. So let's try running it again with thinking on and let's see how it performs. And after running the test, thinking versus non-thinking, we can actually see how much it improved. The model got every single question right when thinking was turned on. So that just lets us know how powerful thinking models are. But there is one big problem. The time to first token increased from under a second to about 19 seconds, which is insane and way too long. But I do think I know a way on how to fix this. And it doesn't mean we're gonna go with thinking or non-thinking, it just means we're gonna use both. And we're gonna use a little trick called routing. So the way that this works is every prompt that we send Pocket is gonna be sent through something called a router. And what the router is gonna do is that it's gonna decide which model to send the prompt to. So if I say hello or tell me a joke or how are you doing, just regular conversation with Pocket, it's gonna send it to the non-thinking version of Qwen. But now if I say explain inverse kinematics or code me a website or a to-do list, whatever the case may be, it's gonna send it to the thinking model because it's a harder question. And a super great thing about routing is that it's very easy to set up. You don't need to train or fine tune anything. So all you need to do is really give examples on the type of prompts you send it to one large language model versus the other, and the router is gonna make an informed decision on where to send that prompt to. So we was pretty easily just able to set up a basic conversation system to where it handles whether to use a thinking model or whether to use a non-thinking model. And that also includes having history and knowing your last messages. So that is already set up with what we have here. But even though we was able to have a conversation through typing and reading text, we also might want to be able to speak to the model and have the model speak back to us. So that's where we're going to use speech to text. So the 2 speech to text models I wanted to test was first, Fast Whisper. And the way Fast Whisper works is that you speak, after you're done speaking, it transcribes the entire sentence. And what this does is make it very accurate even though it might take a little longer for it to transcribe your speech to text. I am testing the quality of Fast Whisper's speech to text. And as you can see, yeah, it looks absolutely perfect. And that took about 1.5 seconds for it to transcribe, which isn't slow, but 1.5 seconds to transcribe and then go through that same routing and letting the AI think. You are gonna feel that and you are gonna notice it in real time. So that's why I didn't just stop at testing Whisper. I also wanted to test Voss because Voss actually transcribes your speech to text in real time. I am testing speech to text with Voss to see how good it is. And it is not good at all. Okay. So one thing I will say is Voss is insanely fast. Like it actually happens in real time as you're speaking, but it's not accurate at all. Unless you're saying something simple like, hello, how are you? That worked pretty well. So I will keep Voss as an option, but Fast Whisper overall is just a better choice. Now with that done, it's time to work on the opposite end of the process, which is converting Pocket's answer, his text, to speech. Now, as far as I'm concerned, Piper TTS is the best thing that we have right now for open source. So with Piper, we usually have 3 different sizes we could choose from. We have small, medium, and large. So I tested all 3 of them, and here's what they sound like.
Hello, my name is Pocket. Nice to meet you.
Hello, my name is Pocket. Nice to meet you. Hello, my name is Pocket. Nice to meet you.
All right, so off the bat, large takes way too long. Almost 2 seconds, no, almost 3 seconds to transcribe a short sentence. Way too long, that's out. And also there's not really a big quality jump from medium to large. To me, both of them sound exactly the same. And at first I was debating between the small model and the large model, but I did a little bit more testing and I realized hearing that super squeaky voice was gonna get annoying over time. Hey, how are you? It goes through, converts, and we start getting the text printed out and...
I'm here to help you with anything. How can I assist you today?
Now we have it set up to where Pocket could talk to us, and of course we could talk to Pocket. But I do want to take the project just one step further because I want Pocket to be able to carry out actions for us. So it should be able to pull the weather from the internet, search the internet. It even should be able to scan our network to see if we have any unknown devices there. So we're gonna set that up using a separate model that's job is gonna be specifically calling tools or calling functions. And the model we're gonna use for this is called Function Gemma. Now what makes Function Gemma so special is 2 things. First, it's an absolutely tiny model. It's only 270 million parameters, which is bite size. But also Function Gemma was trained to output tools, so to output actions. So whenever you ask it to do something, it's gonna give you a function. But there is one problem with Function Gemma. So unlike every other model that we use, it kind of just worked out the box. We didn't need to do anything to it. Function Gemma is going to be bad if I give it custom functions and try to use it. So what we do need to do is fine-tune Function Gemma on our custom data set to make it as accurate as possible to call in our functions. And my goal is to get it to 100%, so we'll see how we'll do. And now if we take a look at the test that we ran, we can see the first question, what is the weather in New York? Function Gemma did the right thing, called the get weather function and passed through New York as a parameter. Turn security cameras on, activate security mode, which is correct. And after that, it got everything correct. Can you scan my local network? Called the network scan, and finally was the current price of the Tesla stock. It did get stock price and passed through Tesla as a parameter. Now that we have our tool calling model set up, to implement this back into Pocket's main core network, all we have to do is add it to the router. And if you're liking the video so far, be sure to give the video a like. And also, if you want to see more of my content, make sure you subscribe to the channel. Now, even though we have the software set up, I still do not think we're using the Raspberry Pi to its full potential. Because one of the benefits of Raspberry Pi is that it's so small, but it's still chained to the desk like a regular computer. So what we're gonna do is make it completely portable so it really fits in the palm of your hand. So the first thing of making the Pi completely portable is, of course, power supply. So we're gonna use this uninterruptible power supply that kind of just connects to the back of the Pi through these GPO pins. That's where the Raspberry Pi gets power. And we also do need to buy these two 18650 batteries separate because it does not come with it. And each of these batteries are about 3000 milliamp hours. So it should get the Pi about 1 to 2 hours of constant use. But of course, if that's not enough, you can always just upgrade and get bigger batteries. The next thing I want to do is kind of future-proof Pocket by giving it some vision capabilities. I'm going to do this by first adding a camera. Of course, we're using a 12 megapixel Ardu camera, but also what we're going to do is use this Halo 8 hat. And what this hat is going to do is allow you to run computer vision models, whether that's object detection, pose estimation, whatever computer vision model you want. You can run that directly on this so it doesn't bog down the Raspberry Pi that's running our large language models. And the last thing that we want to add is this 4.3-inch touchscreen. I will say, if it was up to me, instead I would use a 5-inch touchscreen, and a 5-inch touchscreen that also comes with a speaker and a mic, because one, this touchscreen is pretty small, and if the touchscreen has a speaker and a mic, it makes things a lot easier, which you'll see in the setup in a few. And this is what we have right now for Pocket, a small AI assistant that fits in your hand. But even though everything is tiny and compact, we do have a little problem, the fact that this camera's kind of just hanging. So I decided to make a 3D printed case for this. And one of my biggest worries when designing this case was making sure that I designed it with enough ventilation, because the Pi wasn't already running hot because we're running local large language models on it, of course. But also you're pitting that Halo hat right close to it. Then you have these batteries that generate heat. They're also a touchscreen, all in a tiny, very compact space. So I try to add as much ventilation as possible. And now with everything put together, this is Pocket. So let me go over the custom UI I made so I can show you how to use them. So if you want to speak to Pocket, all you have to do, hello, how are you?
Hello, I'm here to help you.
And then of course you could call tools the same way. What is Google's stock price?
Google, USD 302, 28 regular market.
But you just don't need to communicate with Pocket through the avatar. You can also go to the chat section. So we could create a new chat, and then we could just say, search for the latest AI news. And we have everything here. And you want to use the chat just because everything is in context. And you can also use a keyboard to type to it. You can also do scan my network for any unknown devices. And it scans the network. I gotta make sure I blur that out. But it does scan the network. But one of my favorite things about Pocket is being able to add tasks. And what this allows you to do is be able to task the AI agent just at certain times. So you can either set it up at certain intervals, or you can set it up to run at a certain time of the day. So if we wanted to, we could just make this test one, and we could have it run, of course, we could have it run every minute, or we could have it run, let's say every morning you want to know the weather. So we have this task, and this is obviously just to show it off, that it gets the weather every minute. So every minute it's gonna ask the AI model, get the weather in Atlanta. And what this is gonna do is it's gonna open up this chat section. And as you can see, 2 minutes passed, so it got the weather in Atlanta, got the weather in Atlanta again. And there's actually a little bit of a difference, which is pretty cool. So you could do this with anything, whether it's the weather or getting your network or whatever else it could be. And it also, you guys should remember that we also added a camera to here. So of course you could do just like with any camera, and you can move it around and you could take pictures, but you also press this little button here, and this activates object detection. So you'll see the camera automatically starts recognizing things. And this is ran completely on the Halo hat. So it did the mouse, did the phone, and it's seeing that I am a person. And that's something that's pretty cool about this as well. And that is it for Pocket. If you want to build them yourself, it is completely open source. So check out my Patreon. I have the code in the CAD all posted there. But if you want to run your own local AI, but on your computer, you might want to check out this video right here. And I also want to give a big shout out to all my Patreon members.